The Double Slit Experiment, the experiment that broke reality. What if I told you that reality itself might change depending on whether you're watching it? It sounds like science fiction, but this question sits at the heart of one of the strangest experiments ever performed. The Double Slit Experiment has puzzled scientists for over a century. It helped launch the field of quantum mechanics, challenged our understanding of reality, and revealed a universe far stranger than anyone imagined. By the end of this video, you'll understand why many physicists consider this simple experiment one of the most important and most mysterious in the history of science. At first glance, the experiment looks incredibly simple. Imagine a source that fires tiny particles towards a barrier. That barrier contains two narrow openings, or slits. Behind the barrier is a screen that records where the particles land. Now, if you were firing tiny objects like grains of sand, you'd expect them to pass through either the left slit or the right slit. And on the screen behind, you'd see two distinct bands where the particles hit. Simple. Or at least it should be. Light behaves like a wave. Scientists first performed this experiment using light. When the light passed through the two slits, they expected to see two bright bands on the screen. But that's not what happened. Instead, they saw a series of alternating bright and dark stripes known as an interference pattern. Why? Because waves behave differently from particles. When two waves overlap, they can combine to create larger waves in some places and cancel each other out in others. The bright bands appear where the waves reinforced each other. The dark bands appeared where they cancelled out. This result suggested something surprising. Light wasn't just behaving like a particle, it was behaving like a wave. The shock, single particles do the same thing. Then things got weird. Scientists decided to fire particles one at a time, not a continuous stream. One single particle. They repeated the experiment using photons and even electrons. Each particle struck the screen individually. You would expect each particle to choose one slit and behave like a tiny object, but after enough particles were fired, something impossible seemed to happen. The same interference pattern slowly emerged, the pattern that should only appear if waves were overlapping. But there was only one particle in the experiment at a time. So what was interfering with what? It appeared as though each particle somehow traveled through both slits simultaneously and interfered with itself. A single particle behaving like a wave. This was one of the most shocking discoveries in the history of science. The observation changes the outcome. Naturally, scientists wanted to know what was actually happening, so they placed detectors at the slits. The goal was simple. Watch which slit the particle goes through. And that's when reality became even stranger. The moment scientists measured the particle's path, the interference pattern disappeared. Completely. Instead of the wave-like pattern, the screen showed exactly what you'd expect from two ordinary particles, two bands. It's as if the particle knew it was being watched. When unobserved, it behaved like a wave. When observed, it behaved like a particle. The act of measurement changed the outcome. So what does this mean? To explain these results, physicists developed the concept of wave-particle duality. According to quantum mechanics, particles like electrons and photons can behave both as particles and as waves. Another key idea is called quantum superposition. Before measurement, a particle exists in multiple possible states simultaneously. In a sense, it doesn't commit to a single path. Only when a measurement occurs does the particle appear to settle into one definite outcome. But here's the fascinating part. Scientists still debate what is actually happening behind the scenes. Does observation literally affect reality? Does the wave function collapse? Are there countless parallel universes? Even today, there is no single interpretation that everyone agrees on. So why does the double slit experiment matter? This wasn't just a strange laboratory curiosity. The double slit experiment became one of the foundations of modern quantum mechanics. It forced scientists to abandon many classical assumptions about how the universe works. The principles revealed by this experiment helped lead to technologies that power our modern world. Computers, lasers, semiconductors, medical imaging, and today's cutting-edge quantum research. All of these fields owe something to the discoveries that began with two tiny slits in a barrier. So to conclude, let's recap. Light and matter can behave like waves. Individual particles can create an interference pattern even when fired one at a time. And the act of observation changes the result. A simple experiment revealed a universe that doesn't behave the way common sense says it should. And perhaps the strangest question of all still remains. If particles behave differently when they're observed, what is reality doing when nobody is watching? If you like this video, don't forget to like, subscribe, and let me know in the comments what you think the double slit experiment really means.